Hi my dear students, Assalamu alaikum to all. I warmly welcome to all into this class. We learn what we taken in the last class. Is it? I hope all of you learn what we taken in the last class. Okay. So let me ask some question about that. Are you ready to answer? Good. Okay. What is buoyancy? What is buoyancy? Yes, the body. When a body is immersed completely or partially in a fluid, the fluid exerts an upward force. This force is known as buoyancy. Okay. Then how to calculate buoyancy? Buoyancy is equal to weight of object in air minus weight of object in water. Weight of object in water. Yes. Based on this, in the last class, I gave you two problems. Did you get the answers? Very good. Okay, what was the first question? First question, the weight of a body in air is 120 Newton and weight in water is 100 Newton. Find the buoyancy from the water. Yes, here the weight of body in air and weight of body in water are given directly. So, apply this value in this equation. What is the weight of object in air? 120. Then what is the weight of object in water? 100. Yes. What is the answer? 120 minus 100 what? Yes, 20 Newton. The answer is 20 Newtons. I hope all of you get this. Okay. Okay. What was the second question? The weight of a body in water is 80 Newton. The water exerts a buoyancy of 10 Newton. Calculate the weight of the body in air. Here, we want to find out the weight of the body in air. Buoyancy and weight of object in water is given in this question. What is buoyancy here? Yes, 10 Newton. Weight of object in air, we want to find out. Weight of object in air minus, what is the weight of object in water here? Yes, 80 Newton. 80 Newton. So, how to find out weight of object in air? Weight of object in air is equal to 10 minus 80 is changed into plus. Okay. 10 plus 80. What do we get? Yes, 90 Newton. What do we get? 90 Newton. That is the weight of object in air. Do you get this answer? Very good. Okay. So, now we know that how to find out, how to calculate buoyancy. All of you understand? Then, in your textbook have a table. All of you try to complete that table. First of all, yes, object, weight in air taken as W1. Okay. Weight in water, that is W2. The loss of weight. How can we find out? W1 minus W2. Okay. For complete this table, if we take a stone and a piece of metal, Yes. First we must find out weight in air. If we take the weight of stone is 60 Newton and piece of metal almost same size piece of metal 75 Newton. It is more than this. Okay. Then weight in water 45 Newton. Yeah? Yes. Weight in water it is less than weight in air. We know that. Okay. Then 65 Newton. By given these values, how can we find out loss of weight? How can we find out? Yes, W1 minus W2. What do we get the loss of weight of first stone? 60 minus 45. What? Yes, that is 15 Newton. What is second one? 75 minus 65? 10 Newton. So, we know that this loss of weight is the buoyancy. This loss of weight is the buoyancy. Okay, got it? So, to calculate buoyancy, it is enough to find out loss of weight. To calculate buoyancy, it is enough to find out loss of weight of substance in that fluid. Okay, all of you understand this? Yes. Next, we want to find out what are the factors that influence the buoyancy. What are the factors that influence the buoyancy? For that, I take water, kerosene and saline water in three separate beakers. Water, kerosene and saline water in 3 beakers. Yes. For doing this, it also have a table. Before that, do you know which one has density more? Saline water or kerosene or water? What is mean by saline water? Saline water is salt water. Okay, saline water is salt water. Which one have density more? Yes, we learned in the last year. So all of you look here. Yes, from this we can understand that saline water has density more because it has 1025 kilogram per meter cube. Yes, this approximately value. Okay, this saline water is the density more and kerosene is the density less comparing this water. Okay, all of you understand this? Yes. By doing this, we want a table. Weight of stone in air. Weight of stone in air. Yes. Liquid. What are the liquid here? Yes, water, saline water, kerosene. Weight of stone in liquids. Weight of stone in liquids. Weight of stone in liquids. Then buoyancy. Yes. First we want to find out weight of stone in air. I take a stone and it is what? It is spring balance. The spring balance used to measure the heavy object. So I take approximate value. So I take, yes, this is 10 Newton. Weight of stone in air is 10 Newton. Weight of stone in air is 10 Newton. Then first liquid, kerosene. Then water. Then saline water. Yes. What is the weight of stone in kerosene? Yes. That time I take 7 Newton. Then I am going to measure the weight of stone in the pure water. Yes, what do we get? It is 6 Newton. is 6 Newton. Next and last, I am going to measure the weight of stone in saline water. Yes, it is 5 Newton. It is 5 Newton. So, how to calculate buoyancy? We know that. How to calculate buoyancy? What do you get the buoyancy of stone in kerosene? Yes, 10 minus 7. 10 minus 7, that is 3 Newton. That what is the next? 10 minus 6. 10 minus 6, 4 Newton. Then 10 minus 5, 5 Newton. All of you get these answers: 3 Newton, 4 Newton and 5 Newton. Is there any relation here? Relation between the density of liquid and buoyancy? Yes. When the density increases, buoyancy also increases. When density increases, buoyancy also increases. So, the density of liquid is one factor that influences the buoyancy. Density of liquid is the one factor that influences the buoyancy. Got it? Okay. Based on this, I give you a question. What is the question? Does a ship that enters a freshwater lake from the ocean sink more or rise more? Does a ship that enters a freshwater lake from ocean, it sink more or rise more? Do you know what is the answer? Based on this, you can set that the answer. Do you know what is the answer? For that, imagine that it is the bottom of ship. It is the bottom of ship. You imagine that it is the bottom of ship in the ocean. It is in ocean. Our question is from ocean to it enters from ocean to freshwater. Freshwater. It sink more or it rise more. It sink more or it rise more. We know that in ocean, saline water have density is more. In ocean, saline water have density more. So, buoyancy also more. So, the force or pushing is more. So, the ship rise more. Are you understand? But in freshwater, comparing ocean, in freshwater, the density is less than the saline water. The density is less than the saline water and buoyancy also less than saline water. So, it will not rise like this. It will not rise. The ship will not rise like this. Yes, the ship not rise like this. So, what is the answer? Yes, the ship sink more. When it enters from ocean to fresh water, the ship sink more. Do you get the answer? All of you note down this in your physics notebook. Okay. So, next we want to calculate the buoyancy of two objects. Buoyancy of two blocks. Okay. For that, if we take next we want to find out the buoyancy of two equal weight blocks. Okay. Here I take one copper and one iron. Okay. What are they? Copper and iron. We know that it is the symbol of copper and iron Fe. Okay. Yes. Here I take 5 Newton copper and 5 Newton iron. So, the same weight. So, same weight of copper and iron. It's the same weight of copper and iron. The size is like that. The size of copper in 5 Newton is like that. That is, the volume of is like that. Copper of 5 Newton copper volume is like that. But 5 Newton iron has, the size is like that, it is, volume is like that. So, which one has more volume, copper or iron? Yes, iron has more volume. So, how to find out the buoyancy? Yes, here there are two objects. One is copper and other is iron. One is copper and other is iron. Weight in air. Weight in air. Yes. We take here, yes, 5 Newton. Both of them have 5 Newton. But weight in water, weight in water, and last buoyancy. Yes, weight in water 3 Newton of copper and 2 Newton of iron. So, what is the buoyancy of copper? 5 minus 3 what? Yes, 2 Newton. Buoyancy of iron, 5 minus 2, that is 3 Newton. From this, we can understand iron has more buoyancy. Iron has more buoyancy. Iron has more volume and iron has more buoyancy. So, we can understand that the volume also. The volume is another factor that influences buoyancy. The volume is another factor that influences buoyancy. So, what we learned today? Yes, we learned that there are two factors that influence buoyancy. One is density and other is volume. Got it? All of you understand this? Yes. So, I give you a work for you. All of you write this question in your notebook. It is taken a wooden block, Christian. Block and iron block, wooden block and iron block of masses 100 gram each. Which of them will have? Which of them will have more volume? More volume. And the question, which is experienced more buoyancy? More buoyancy. All of you understand the question? It is taken a wooden block and iron block of masses 100 gram each, same mass. Which of them will have more volume? And B question, which is experienced more buoyancy? Okay, all of you must do this work. Okay, let's wind up our class. Okay, thank you. Assalamu alaikum.